Hi, my name is Michaela Bouffard, and I'll be introducing a low-cost, high-quality solution to mitigating road mortality in turtles. We benefit greatly from having turtles in our ecosystem. They allow nutrients to be transferred between the aquatic and terrestrial environment, they clean our waterways of bacteria and decaying matter, and they even act as gardeners by dispersing seeds. These are called ecosystem services, and these services can be measured by the turtle's biomass. Biomass is how much turtle mass is available over a given area. Compared to mammals, turtles have a relatively high biomass, which means that their presence makes a huge impact on what they can do for us. Less biomass means less favors from the turtles. Unfortunately, turtles are in trouble. Globally, 61% of turtle species are listed as threatened. When we bring this closer to home, all 8 of the turtle species native to Ontario are considered at risk under federal or provincial legislation. Road mortality is one of the leading threats to our freshwater turtles. If you look at this road density map of southern Ontario, each line represents a road. In some areas, you can't travel more than 1.5 kilometers before encountering a road. Turtles can have home ranges of up to 8 kilometers, so as you can imagine, this poses a serious problem if you're small and slow. As turtles migrate from hibernation sites to nesting areas in summer areas, they may have to cross up to 8 roads just one way. As human-made threats increase in the face of development, there are ways that we can mitigate their impact. These include the use of barriers and ecopassages to allow turtles to move safely under the road by creating corridors, artificial nesting sites to provide suitable nesting habitat before the turtles need to encounter a hazard, and head starting, which increases the survival of juveniles who are often eaten by predators before they can reach maturity. Ex situ egg incubation and nest protection are two options to prevent predators such as raccoons and foxes from eating the eggs before they hatch, either by incubating the eggs ourselves under permits or putting a predator exclusion cage over the top of the nest. And then habitat restoration, which can be done to replace damaged critical resources the turtles need to persist. The mitigation method that I would like to focus on is the use of barriers or ecopassages to keep turtles off the roads. In the past, researchers have used various materials and designs to mitigate road mortality in turtles, but with varying levels of success. These outcomes can act as lessons to direct new designs and increase the effectiveness of these projects. An important factor in determining the success of a barrier is the quality of the material. Low-quality materials can fail, resulting in increased road mortality. This is what happened when silt fencing was used on a major highway. This material was not durable and quickly tore as a result of the construction process and demands of our northern seasonality. The result was snakes and turtles entering the highway through the rips, but being unable to find a corresponding hole on the other side of the road. This caused them to ping-pong across the road and led to an increase in road mortality. When placing mitigation barriers, it's important to know where the spring floodplain is and plan accordingly. If the water rises, it lowers the height of the barrier and can allow turtles to climb over the fence. Other projects have been done in the past using high-density polyethylene, or HDPE, as a barrier. This is not an ideal material because HDPE can become brittle and break, shift in response to frost, or can be difficult to stabilize. As the material is installed in one long continuous piece, these shifts can be labor-intensive to correct, and if not fixed in a timely manner, they can result in allowing reptiles to enter onto the roadway. If the backfilled slope has failed or eroded, animals can then become trapped on the road. This concern about backfilling HDPE is because the material is slick, making it difficult for soils to remain in place. The holes at the top of the designs can also attract snakes, but then they can't get back out. While concrete barriers are less likely to shift or break, they're expensive and installation poses a challenge. Then we have vertical fencing, which can include sheet metal, geotextile fencing, or even wildlife fencing. This design does not incorporate jump outs for animals to escape off the road if they do end up wandering onto the roadway. Mitigation systems should be one-way semi-permeable, meaning that wildlife must find safe egress and be able to move off the road in one direction, but not back onto the road in the other direction. In the land between especially, and in parts of rural Ontario, municipal and county arterial roads tend to travel through significant wild spaces and mosaics of wetlands. These represent some of the final strongholds for turtles, and these roads also carry high volumes of traffic, making them high-risk roads for reptile mortality. Mitigation is essential for maintaining these populations. However, these jurisdictions also tend to have budget constraints. So, how can we mitigate road mortality in an affordable and high quality way while integrating the lessons that past projects have taught us? We have avoided the cost quality trade off by creating a design that consists of durable and affordable materials. These consist of drinking water standard coated steel barrels and 1-inch rolled cold steel buttressing. The barrels are cut in half, with one side acting as the barrier and the other side welded to the back for added stability. The use of steel bars allows for added support. The back perspective provides another view of the half barrel and angle iron used for added support and stability. Also, the material and design is easy to backfill with topsoil and gravel to ensure animals can travel over the top to reach safety. In this way, the barrel design is a one-way fence, which becomes both an exclusion fence and a jump-out feature for wildlife. They've been tested for 3 years in highly erodible sites and are very stable. There are 3 main scenarios where this design can be applied. The first is below the grade of the road. This is done by excavating into the ditch and using gravel and topsoil to backfill a ramp to the top of the barrel arch. This backfilled slope acts as one big jump out, allowing wildlife to leave the road but not enter. The barrel system is supported by a foundation of riprap and gravel. Excess water can drain off the road past the shoulder rounding and down the slope of the backfill, and native grasses or forbs can be planted on this surface. One important aspect of this scenario is the use of cedar posts to prevent cars from pulling over and onto the barrels, as they've not yet undergone material strength and weight-bearing testing. The second scenario involves a barrier being installed at the same grade as the road. A ditch is excavated between the road and the barrier to allow for water drainage, and this dip also prevents cars from pulling off onto the barrels. Therefore, cedar posts are not required. And similar to the previous scenario, a foundation of riprap and gravel is used to support the design, and the sections are backfilled to create a jump out or ramp that animals can traverse to reach safety. Lastly, the barrels can be placed above the grade of the road and backfilled at an incline to allow animals to exit the roadway. Without a significant road shoulder rounding, the use of a Big O drainage pipe may be used to allow for water movement and drainage, and at a distance to allow for plows and snow piling to accumulate without interfering with infrastructure. Similar to the first scenario, cedar posts are needed to keep vehicles away from the barrels until material testing is completed. A huge benefit to this system is that installation and removal is quick and easy. This can either be done by hand or with the help of a mini excavator, so heavy equipment isn't needed. Problem with roads intersecting turtle habitats is it causes fragmentation of the landscape and prevents the movement of turtles between wetlands. Turtles have a relatively large home range, and each wetland or aquatic habitat can represent different resources the turtles need throughout the year. This is comparable to how we have a living room, kitchen, and bedrooms in our homes. By integrating an eco passage or tunnel under the road, we're allowing connectivity between the rooms of their habitat. Without eco-passages, barriers are problematic. Similarly, without barriers, eco-passages are also ineffective as turtles need to be funneled into these corridors. As with all designs, there are some caveats when implementing the barrel system. First, the barrels must have a rust-proofed coating to allow them to maintain their durability and integrity. They must also be sprayed on the welded sites immediately after they're assembled. In order to compensate for the large size of snapping turtles, and because turtles can't move backwards, we've set a minimum distance between the bottom of the support rod at the base of the lid and the widest part of the barrel's arch. This distance should be no less than 62 centimeters, and this standard is only for Central Ontario snapper populations, as they exhibit geographic size variation and may not meet the requirements of southern snapping turtle populations. Riprap should be used as a foundation to the barrels, but not as a backfill. Exposed riprap is a hazard to hatchling turtles because they're not able to move across it. If they become stuck in the riprap, it opens the door to being eaten or drying out in the sun. And to reiterate, if the design is installed above or below the grade of the road, cedar posts or guardrails must be used to prevent the cars from pulling onto the road shoulder and onto the barrels. This addition can be excluded once material strength and weight-bearing testing is complete.